Good evening, sir.
Yes, good evening. Tell me, all these things have you written?
Which one, sir? I can't see your screen.
Oh, 1 minute. That is only yesterday what I taught you.
Yes, sir, I've written everything yesterday.
That these are the things. Tell me, what is Lorentz force?
Sir, force experienced by a particle moving in a magnetic field is Lorentz force.
What is its formula?
Sir, F is equal to QVB. Q into V cross P or QVB sine theta.
Good. What is the rule used to find out the force?
Sir, left hand rule, Fleming's left hand rule.
State the Fleming left hand rule.
The Fleming left hand rule states that the direction of the current is the direction of the direction which the central finger was direction of the central finger is pointing, and the direction of index finger is direction of velocity, and thumb finger is the direction of force.
Yes. You have to statement you have to do properly. Okay. According
Yes, sir.
to Fleming left hand rule, imagine that your left hand is stretched, left hand three fingers stretched in such a way that three fingers you have to name them. What are the name? Forefinger, middle finger, and thumb, mutually
Yes, sir.
perpendicular to each other. If
Yes, sir.
the motion of the charged particle, that is velocity, it is in the direction of the middle finger, and magnetic field in the direction of the forefinger, then we get force which is in the direction of thumb if it is positive charge is moving. So if it is negative charge, you have to apply accordingly. Okay.
Yes, sir.
What is the formula in terms of the current? Lorentz force formula?
Um, 1 second, sir.
F is equal to ILB sin theta.
Okay, yes, sir. Yes, sir.
I means current, L means length of the conductor in the magnetic field. Okay. B is uniform magnetic field. Theta is the angle between the current element and magnetic field. And always this force is always perpendicular to the both magnetic field and current. What is the formula for force between the two infinitely long parallel currents carrying conductor conductors?
Um, 1 second, sir. I think I remember, sir. 1 second. Sir, uh,
Force per unit length is equal to mu naught I1 I2 by 2 pi r.
yes, sir.
So much time you are taking, you are going to write the test. You should remember, then only there is a chances of getting good marks in your exam.
Yes, sir.
Okay. Definition of 1 ampere.
So yes, sir. 1 ampere is the amount of force required to move. 1 ampere is the amount of force required to move. Required. 1 second, sir. Uh,
1 ampere is that current when it is flowing in two parallel conductors kept at a distance of
generates a
1 meter.
force of
Yes, then
2
force
pi
per
into
unit length is equal to 2 into 10 to the power of minus 7 Newton per meter.
minus 7. Yes, sir.
If you are that way, it is very difficult, my dear Pranav.
Sorry, sir, actually, like in school also a lot of things are going on, so
Yeah,
I'm getting the
I know.
concept of the
I understand, but at least 15-20 minutes before when you come to my class, if you refer and come, then class will be lively, goes.
Yes, sir.
Otherwise, it all waste only because the things are very tough going on. I am going to ask those things only which I taught you very well. Okay. So 1 ampere is that current when it is flowing through two parallel infinitely long current conductors in each kept at a distance of 1 meter, then the force Lorentz force experienced per unit length is equal to 2 into 10 to the power of minus 7 Newton per meter. If you tell that, it is fine. Okay, you can try once again. 1 ampere is that current.
So 1 ampere is that current when moving across two parallel wires at a distance 1 meter from each other generates a force of 2 into 10 power minus 7 Newton per meters
which
per unit
generate
length.
which experienced force of 2 into 10 to the power of minus 7 per meter Newton per meter. Okay, good. Representation of the field due to parallel current. The diagram, one is if the two currents are
Yeah,
parallel
yes, sir, yes, sir.
in the same direction.
Clockwise and anti-clockwise.
Yes, if two wires are in the two wires, the current is in the same direction. Will it attract or repel?
Same direction it attracts, sir.
Yes, in opposite direction it will repel. Why it will be attract?
Yes.
Because the magnetic field which is developed, pressure is created in such a way that they come to close to each other. That means attract to each other. And why they repel? When the currents are opposite direction, the magnetic field is such a way it will develop pressure which separate these two parallel wires. Okay, then what is
Yes,
torque?
sir.
Torque is what is a representation over torque. There I told you both the things. Electrostatic torque experienced by a dipole, and again I told you very clearly that magnetic rotational force experienced when a current carrying loop placed in the magnetic field. So that is ILB sin theta. Correct na?
Yes, sir.
IAB sin theta. So IA is a magnetic dipole moment. B is magnetic field. Okay, sin theta is angle between the magnetic dipole moment, that is area vector, and magnetic field. So I into A is called magnetic dipole moment. So this magnetic dipole moment is the product of current and area, and its direction is in the direction of area vector. So you have
Yes,
to
sir.
remember all these things, and then derivation. Okay, derivation which I have to do today is what is that? Textbook derivation. So I think this is all well known to you now. Is it coming?
Yes, sir.
If you have any doubt, you can ask. I am just skipping over all these things which I already taught you in class 2 of moving
Yes.
charges in magnetic field. This is a third class going on. Why? Fine. So this
Yes, sir.
the thetas are kept over there. Then you will get all these three cases. They are special cases which are going to come in objective type question, which I told you already. Then this is a rule. I think you are very well known to this rule. And this is one. This is the one. F is equal to QE plus QV cross B.
Yes, sir.
What is this one?
QE. So that is the Lorentz force. So like same expression, sir. When there's an external
No,
magnetic
it is
field also.
not same expression. The
When there's an
title
electric
you
and
read.
magnetic field both, then you have to use this
Yes,
expression, sir.
correct. When the charge is moving in uniform electric and magnetic field. This is a very important question going to come. When these two forces are equal and opposite, net force will become zero. Then with this QQ will get cancelled. V is equal to E by B will come. Right?
Yes, sir.
V is equal to E by V become magnitude. Right? So
Yes, sir.
this derivation, whether you are aware or not, I don't know. That is taught in the chapter 2. That is velocity vector. And with the help of that, speed of light 3 into 10 to the power of 8 meter per second can be calculated. Okay now.
Yes, sir.
Okay, this is the another derivation which I taught you very clearly, that current carrying conductor placed in the uniform magnetic field, ILB will come. ILB sin theta will come. This derivation, very simple steps you remember. That is this one. Electrons you take, convert into the current, then you will get this equation, which I explained you very well. Hope you understood.
Yes, sir.
Right, this is the one. First one is force on the second one due to the magnetic field of first one. It will be towards the first conductor and they are both the currents are in the same direction. If it is second one is the force experienced by first wire because of the magnetic field of the second wire, it will push towards this. So they will get this. Both the magnitude are equal and opposite, and it will be attracting, and its formula will become this much. L, when you take left side, force per unit length will come. Force per unit length is mu
Yes.
naught I1 I2. I1 is 1 ampere, I2 is 1 ampere, R is 1 meter. Then force per unit length will come ampere circuit law. This is what it is, attraction. This is what it is, ripple. Sorry. Okay, Ampere's law, once again you read clearly. One, you read yourself.
Yes, sir. 1 ampere is that current which if passed through two parallel conductors of infinite length and place 1 meter apart in vacuum causes conductor to experience force of 2 into 10 power minus 7 Newton per meter if of length of the conductor.
Here pressure is pushing these two conductors together. So it will be, if the currents are moving upward direction in the both the wires, the anti-clockwise will be magnetic field which is bringing very close to each other. It is appears to be attracting. And here what it is, both are in opposite direction. It will be clockwise, one is clockwise, another one is anti-clockwise direction. So they will be opposing to separate them. So repulsion.
Yes, sir.
Okay, this is the one long derivation, but short derivation is given in the textbook that will go through. Okay, short derivation also there. Here I kept it here. What happened? Oh, 1 minute. I am going to start textbook version. textbook version. Textbook. This is a current magnetic field. Magnetic field. Magnetic effect of current. Third also there. And where is it? Which one I am discussing? Your magnetic with the problems. Yesterday I taught you other one is not. Okay, in the textbook we will do otherwise. What is the chapter number 4? You have any doubts? School or other one? Any small doubts are there? You can ask.
No, sir. Sir, like tomorrow, when you have class, can you just revise the young double slit experiment and then the formulas and all of that related to wave optics?
Yeah, you have Saturday test.
Yes, sir. Saturday I have wave optics, the only Young's double slit experiment part, and then I also have electromagnetic waves.
Okay. Electromagnetic wave I would have taken now itself.
No, sir. I'll just finish up all the backlogs first, and then it'll be easier for me to do it on my own
Okay,
afterwards.
okay. This how to skip. This one I don't want. Okay, this you understood, is it not? Sprinkling of iron filings will show pattern of magnetic field around the current wire. And this is the magnetic force which I already told you. If the charge is moving in electrical field, QE. So that will be Q small q r square. It is proof of your Coulomb's law. Right? This is Coulomb's law is F is equal to Q1 Q2 by 4 pi epsilon naught r square. And here is electric and magnetic Lorentz force. So here both the fields are there. QE is vector quantity, V cross B. Both are added as I explained you. Right? How to skip this one?
Sir, how to increase the size?
Ah,
Sir, click control on your keyboard and then zoom. Like, you have
con-
mouse or laptop, sir?
mouse also there.
Sir, you have laptop or desktop, sir?
Laptop.
Yes, sir. So in the touchpad, just like how you do in phone, same thing you do, sir.
Ah, zoom
Like in
here.
phone to zoom, you take two fingers and then put, yes, sir, yes, sir.
But it is going big. This one I don't want, this portion.
Uh, Sir, click on the side part, the three lines.
Okay. Oh, right. Thank you.
Yes.
Sometimes we'll forget soon, like happening to you. This question we have to do now. This we have done yesterday, is it not?
Yes, sir.
Then this one we have done yesterday. And this one we should do now. What is the question? Motion in magnetic field. What is motion? Charge, positive charge. When it is entered with velocity v, it experiences force. That experience force is towards the center. Centripetal force will act on it so that the charge move in a circle. Tell me what did I say? All sentence you repeat in your Hindi or English or whatever language. Even Kannada, if you tell also, no problem.
Sir, can you repeat once again, sir?
Okay, in the diagram,
Yes, sir.
okay, this cross is magnetic field going into the screen or into the paper. Okay, here is positive charge, that is
Yes, sir.
proton. When it is enter with velocity v, it experiences magnetic force. The magnetic force is perpendicular to the v and also perpendicular to the magnetic field. So it will be directing towards mean position, right? And it is directing towards the center. So that will be called as centripetal force. Centripetal force is a force act on a body which keep the particles move in a circle.
Yes, sir.
And pseudo force is the force which is developed because of centripetal force and equal and opposite direction away from that. You know that pseudo force and all in 11th class you are studying. So
Yes,
this
sir.
is centripetal force. Now you tell me, what did I say?
Yes, sir. The charge Q, which is positive charge, when it enters into a magnetic field, then it moves when it's moving with a velocity v, it experiences centripetal force,
Which is
which keeps it in a circular path.
which is perpendicular to the V. See, it is perpendicular
Yes,
to
sir.
the
Yes, sir.
V, and also perpendicular to the that magnetic field is actually entering into the paper, na? So it is perpendicular both the field, which I told you already. Which two vectors are perpendicular to each other? That I told you, it is perpendicular to the V, it is perpendicular to magnetic field. So the keep on move in a circle. So this is called uniform circular motion, and we can apply those rules which you have studied. So what is the centripetal force equation? mv square by r. This I think you come across already in 11th class. This equation I am talking. Okay,
Yes, sir.
1 minute. This is actually something went. I will open once again. 1 minute. This I want to open with this Microsoft Edge so that I can write also. Okay. Which page number? Simultaneously, you can tick mark in your notebook so that it is easy for you to refer. Not notebook, in your textbook you can note down. Okay. Actually, this is the one which I have to do. This one. So based on the figure, F is magnetic Lorentz force, which is equal to QVB sine theta. Here theta is 90 degrees. So V and B are 90 degrees. So it will become sine 0. Sine 90 is 1. So you will get QVB. This is clear.
Yes, sir.
And this one is ninth class you have studied. The force which is towards the center when a particle is moving in uniform circular motion, mv square by 2. Okay, na?
Yes, sir.
Very good. Then one question they will ask you to derive the expression for what? Expression for radius of no radius of the charged particle moving in a uniform moving in a uniform circular motion in the magnetic field. This is the expression they are going to ask. Okay, you understood here? What is F here? Centripetal force. Centripetal force is F is equal to, tell me.
So, F is equal to mv square by r.
Okay, that you understood now.
Yes, sir.
And then
Sir?
no, nothing. I am just showing it. See here, this is the one I am showing. Understood or not? The question comes
Yes, sir.
this radius of circle when a charge is moving. Then if it is moving perpendicularly, if it is not moving perpendicularly, what happens? Tell me. If it is not moving perpendicularly, then the velocity vector is not a perpendicular in the magnetic field. It is with an angle theta. So at that time, what you will get here, the path will no longer uniform circular motion. It will be spiral like this. Understood?
Yes, sir.
The distance between the each circle is equal to pitch. They will ask you once they asked what is pitch. Pitch is the distance between the two spiral rounds or adjacent spiral rounds. Okay, you can read here the circle described by a charged particle. The large momentum, larger is the radius, bigger the circle. Okay, and V is equal to R omega. We know, you know already. And omega is angular frequency 2 pi nu. This is also they will ask sometimes. Find what is angular frequency. Angular frequency is how much here? It will come here. Omega is V is equal to R omega. R is already we have studied on the top. This is the one we got it. Here this is the one. Okay, and then you will be getting here omega is, you understand, means you 2 pi nu. What is nu?
Frequency, sir.
Frequency. What is omega?
Angular velocity.
Okay. This is equal to how much? It is given here.
QB by M.
Yes, Q, because omega is omega into R. No, V. Omega
Yes,
is
sir.
equal to V by R. Omega is equal to how much? Actually, yeah.
V by.
No, actually, what QVB? How you got it? This R is submitted. V is equal to omega R. This derivation okay, or I have to elaborate?
No, sir, I understood. Like, I've done it before, sir.
Then you tell me now why unnecessary wasting time. That pitch also you did.
Pitch, no, sir.
Pitch is this one. This one. Pitch is equal to horizontal distance. Horizontal distance is equal to horizontal velocity into time period. Time period what we calculated just now. Time period is 2
Pi
pi
by
by
omega.
omega. 2 pi by omega. So 1 by nu. That 2 pi by omega you can submit here, you will get pitch value.
Yes, sir.
What is parallel component of velocity? Here, two components are there. One is vertical component, another is parallel component. Parallel component is V cos theta. Vertical
Yes.
component is V sin theta.
V sin theta.
Okay. So your parallel component
Yes.
into T will be distance from here to here. This distance. This distance is called pitch. Try to understand. Okay, now.
Yes, sir.
So this is called pitch. Pitch is what? Horizontal distance. Horizontal distance is what? Uh, Horizontal distance is velocity into time. Which velocity you have to take here? Parallel. Okay, now.
Yes, sir.
So parallel means, may I derive and show it? You understood?
I understood, sir.
Okay, do the problem. 4.3. Read the question.
What is the radius of one atom with electron? Mass 90 10 minus 3 kg and charge 1.6 10 minus 19 coulomb. Moving at the speed of 3 into 10 power 7 meters per second. The magnetic field of 6 into 10 power minus 40 star of 23 electron. What is the frequency calculated energy the electron volt?
What are the things are given?
So they're given the speed of the particle, magnetic field, and charge and mass.
Mass is not given. Mass of the particle.
Given, sir.
So mass is given, V is given, Q is given, B is given. Submit it, you will get radius. Then
Yes, sir.
what is frequency? Frequency is
2 pi by omega, and omega you can find V.
yes.
Omega is
So you get 17 megahertz will come. And what is kinetic energy? Half mv square.
half mv square.
So m is mass of charged particle. So minus 31 means which mass it is? Electron or proton?
Sir, electron.
Electron is and velocity is given. Just calculate. And conversion, joules to electron volt. 1 electron volt is given this much. So this many joules, how many? So 1.6 into 10 to the power of minus 19 joules is equal to 1 electron volt. Okay. So for
Yes,
this
sir.
many joules, how much means you just divide it. You will get electron volt. Conversion you understood?
Yes.
Tell me what you should do for conversion. How you got this, 1 electron volt?
No, sir.
1 electron volt is what? Electron and volt. Q into V.
Okay, yes, sir.
Energy. Because you have studied now
Yes.
already. What is that? Work is equal to what? E is equal to
Force into distance.
W by Q. W is equal to
Yes.
QV
VQ.
and Q is equal to E and V equal to 1 volt. So what will be the energy? Energy or
Charge of electron.
work is equal to, in place of Q you have to put E. So 1E. You have taken 1 electron means 1E. 1E into voltage, how much you have taken? 1 volt. 1 volt. It will become 1 electron volt. So what is the definition? 1 electron volt is the energy gained or lost by the electron when it is moves between the potential of 1 volt. Potential difference of 1 volt. Tell me 1 electron volt definition.
Sir, 1 electron volt is the velocity of electron when it moves through 1 volt potential.
Listen carefully.
Sorry, work done by electron when it moves through 1 volt potential.
No. 1 electron volt is the energy of an electron when it is moves in the potential difference of 1 volt.
Yes, sir.
Tell me.
1, 1 electron volt is the energy of electron when it moves through potential difference of 1 volt.
Very good. So 1 volt is how much in joules?
1.6 into 10 power minus 9.
Very good. So how you got it that value? May I show you here? No need.
I understood, sir.
Very good. Next. So pitch is clear. This you write and show me tomorrow. This is all over
Yes, sir.
Bird Sarvet law. Okay. This is all clear. Okay. This is the one equation is coming. This is the one derivation always coming in the exam. What is the derivation? This one. Show that epsilon naught mu naught is equal to 1 by c square. This one. You know this derivation is taught in the school?
No, sir.
No, it is a value
Okay, okay, so yes, sir.
May I skip?
Yes, sir.
What is electromagnetic waves? Also, it will come this equation. I'm going then skipping now.
Yes,
Again.
sir.
Okay. This one. Question.
An element delta L is equal to delta xi cap is placed at the origin and carries a large current I equals to 10 amps. What is the magnetic field on the y-axis at distance 0.5 meter at axis delta x is equal to 1 centimeter?
Okay. Tell me. You know the answer? Diagram is
No,
clear.
sir. Yes,
Check
sir.
the answer. If you don't understand, I will tell you.
Yes, sir. I'll just read it once.
Okay, na?
One second, I'm still reading. Understood, sir. No, sir. Can you explain once?
Yeah, okay. See, Bayard law is it clear?
Yes, sir.
Right, when it is clear, mu naught 4 pi I dl. What is asking here?
Magnetic field.
What is the magnetic field on the y axis at a distance of 0.5 meters? So, current element is given, distance is given, right? Then, what is the formula? That Bayard law, mu naught 4 pi value you know, I you know, dl you know, dl is given, that is how much? 1 centimeter, that you convert into meters, 10 to the power of minus 2.
0.01 meter.
Okay, that you have to submit. Sin theta is angle. How much it will be? Angle between DL and R
90.
90. So 1. R is distance. You got it, magnetic field this much.
Yes, sir.
It's only magnitude you got. But direction when you want, you have to go cross rule. What is the cross rule in the Biot-Savart law? R cross L, DL cross R. So X and Y will give you K. In your 11th class, you have studied this. Am I right?
Yes, sir.
So this is the what are I and J and K. So this
Long-term
is the
unit vector.
what are I and J and K. So
Orthogonal unit vector.
unit vector.
Yes, sir.
It is they are unit vectors. One is
Yes, sir.
x direction, other is j direction. And if I and j are known, then it will become k. J and k means because you are taken dl. Dl is I, R is
I
j,
see.
I cross j is k. So the direction is in the direction k direction, positive direction. So it will be going. This is x, this is y, then this will be which side? This will be z.
K.
So that way you have to do. So k unit vector you have to write.
Yes, sir.
This is I have taught very clearly. I don't want to discuss. In PowerPoint presentation we did.
Yes, sir.
Okay, this now Ampere circuit law we need to do now. I think which one this or this magnetic field also I taught you.
Yes.
Thumb rule we have seen now. This question we have to do now. Let's start this question.
So one second. Can I get the door for somebody's?
Yeah, go ahead.
Yes, sir. A straight current carrying wire, straight wire carrying current of 12 amp is bent into a semicircular arc of radius 2 cm as shown in figure 4.11. Consider a magnetic field B at the center of the arc. What is the magnetic field due to the central straight segments? In what way the contribution of B from semicircle differs from that of current loop A, circular loop A? In what way does it resemble? Would your answer be different if the wire were bent into a semicircular arc of same radius but in the opposite way as shown in figure 4.11b?
So now current is entering from this side. Which side current is entering? From here. So left to right and going round. If it is in circle now, it will produce some magnetic field over here. If it is going into the paper, outside the paper here, magnetic field. If you use the right hand thumb rule,
It is going out of the paper, sir. Out of the paper.
check once.
Yes, sir, out of the paper.
Current is this one, na thumb, right hand thumb rule you have to use. Right hand thumb you put in the direction on the top, encircle
Yes, sir,
fingers
it's
are.
going towards the right, no, sir. Right means it's coming out of the plane.
No, it is not right. I am talking about here. This side.
Yes, sir, the direction
This
of current is towards right, no, sir.
no, this one I am talking here. Here you apply, you put the thumb, right thumb that side, and encircle fingers. You see which side it is coming towards you and going inside. You put your thumb there,
Yes, sir.
inside or outside.
Outside, sir.
Magnetic field is coming outside.
Yes, sir.
Here,
Yeah, both sides outside, sir.
now read the answer. You are not understanding.
DL and R for each segment of the straight segments are parallel. Therefore, DL cross R is 0. Straight segments do not contribute to magnitude of V. For all segments of semicircular, DL by DL into R, DL cross R are all parallel to each other. All such contributions add up in the magnetic field, and the direction of V for semicircular arc is given by the right hand rule, and magnitude and circular loop thus B is equal to 1.9 to 10 power minus 4 Tesla, normal to the plane of paper going into it.
Going into it. You understood?
Yes, sir.
You are wrong or I am wrong?
I am wrong, sir.
Then why you properly and not answered?
Okay,
Still,
so it's going into the plane. I use the thumb rule.
you are using thumb rule. Na? See, here thumb you indicate in the direction of current and encircle fingers. So, okay.
No, sir, this is Fleming's rule. No, sir, this Fleming's rule will be different.
Which Fleming rule? Fleming right hand rule and left hand rules are there. Here Fleming left hand, Fleming right hand we are not using. We are using only right hand thumb rule. Right hand thumb
The
rule.
thumb rule means it will be going out of plane, no, sir.
You open this. Actually, your screen I want to see. You see my screen. This is the one, no?
Yes, sir, 1 second.
So this.
Sir, the direction is towards the right, no, sir. So
Okay, right. This is the right. You are seeing my.
So it will be coming out of the plane towards you, no, sir.
Yeah, it will be good. Right and right means this. This is the current direction. I am putting in the direction of the current. Okay. Encircle fingers which side it is going. Coming out and going inside. Here. This is the pointer.
Yes,
Which
sir.
direction? This which direction this. Now I am taking. This is the current direction. My thumb is current direction. This is your magnetic field.
Yes, sir.
So which direction
So
it
like
is?
it's coming out of the plane, no, sir. If you point from that side.
It is on the top. It is coming, but when you are coming to the center,
Okay, it's going into the plane, yes, sir.
got it.
Yes, sir.
Many children writes wrong. I don't know why. They don't apply properly. Very interesting. Okay. Right. Next. Tell me. Same magnitude, opposite side direction. In this case, opposite. Why it is opposite? So in this case, is current is this side. See again. You see here. Current is this side. Okay. Encircle fingers are
Yes, sir.
coming out. When you see at the center, see at the center here. Here you see. This is thumb direction. Okay. Fine. And encircle thumb direction of right hand. And encircle fingers at the center will be coming out or going in.
Going in, sir.
Going in.
Yes, sir.
Magnetic field is going in or outside, I am asking. But in the answer it is given something wrong. Then this is what opposite direction they said. Here in the first case, where is going? First case is normal to plane of the paper going
Upwards.
in it, going in into it means inside. Here
Yes, sir.
it will be outside. Still
Okay,
you
yes, sir.
still not in a
Understood.
position to apply.
Understood, sir.
Okay, right. Next, how to calculate magnetic field? Half of the center. What is the formula here given? This is the formula you have to use. This formula divided by 2. Why divided by 2? Only half loop. Mu naught I by 2r. I is given. Mu naught you know 4 pi into 10 to the power of minus 7. R is given. Radius is given or not? Radius is
Given, sir.
given 2 centimeters and current is given and formula is mu naught. Tell me what is the formula?
Yes, sir. Mu naught I by 2 pi r.
Oh, 2 pi r, 2r na. Just now I shown you 2r,
Yes, sir. Yes, sir. Yes, sir. Sorry, sir. Yes.
2r divided by 2. Why divided by 2? Because half circle only. In first
Yes,
case
sir.
there is no magnetic field in the here. Here no magnetic field. Here also no magnetic field. But magnetic field is inside the circle. Half circle. Half circle means you will get here mu naught I by
2 r.
mu naught I by 2r. Alright. So you divided by again half. Why half? Only half circle. So you will get here mu naught I by 4r. This is the answer.
Yes, sir.
I is given, R is given. Why 4? Because you know. Next. Next question. Read the question.
Consider a tightly wound 100-turn coil of radius 10 centimeter carrying current of 1 ampere. What is the magnitude of magnetic field in the center of the coil? Yes, sir. So it will be mu naught Ni because there are n turns instead of mu naught I by 2r. And then same formula left of place.
Okay, next. Now we are doing Ampere circuit law, which I told you. Where is the statement you search? Your statement is this. This is the law.
Yes, sir.
This is a statement. Read once.
The sum of then tends to it. Ampere's law states that the integral is equal to mu naught times the total current passing through the surface. That is, surface integral of B dot dl is equal to mu naught time.
Total current passing through the surface. Which surface? This is a surface. Okay. In the surface, this current, whatever current is passing, that is I. So this is the formula. Okay.
Yes, sir.
Some important points related to ampere loop. First one you read.
B is tangential to the loop and is a non-zero constant B. B is normal to loop or B vanishes.
It is tangential. Second, B is normal to loop. Tangent always normal to the loop, na?
Yes, sir.
Several application, much simplified version proves sufficiently. We shall assume that in such a cases, it is possible to choose the loop called ampere loop. This is called ampere loop. Which one? This one. Okay.
Yes. Yes, sir.
So the next, if it is total circumference, what is the length of this circle?
2 pi r.
Or capital L. If it is capital L is, so what is given?
Yes, sir.
2 pi r. So this is the derivation for straight current wire, which I taught you already. Yesterday I taught you, na?
Yes, sir.
Okay, now let us do this. This is from this chapter, na? Every question is important. Every question asked in the CBSE board, even in your JEE. So if you are not thorough with these things, na, gone. Your rank will go somewhere, not in thousands, not in hundreds. It is up to you how much you put efforts. Very, very difficult question it is. If you are good enough in mathematics, you can solve it easily.
Yes, sir. Figure 4.3 shows a long straight wire of a circular cross section of radius A having steady current I. The current I is uniformly distributed across the cross section. Calculate the magnetic field in the region R less than A and R greater than A.
So outside they are asking magnetic field, inside they are asking, on the surface of the conductor they are asking. Okay?
Yes.
So three cases are there. Now you have to do three cases. Answer you want to see and try to understand?
Yes, sir.
Come on. R is greater than A. Well, there is a current, there are the magnetic field or not. Outside is very simple. There is a magnetic field which is mu naught I by 2 pi r of straight current wire, and this is just now we derived. This is outside. So outside B is proportional to 1 by R. If R is increasing, B will decrease. So you will get graph like this. Fine. This is the graph you will get. This is R. This is B. Okay. So
Yes.
next one is what it is. Oh, sorry, here something went wrong. First case, okay, correct only. In the first case, B is proportional to. We have done second case. This case, this is the right only answer. Okay, tell me. Outside is decreasing, inside
Inside it's increasing, sir.
R is less than
Because it's
A.
direct proportional to R.
How this answer has come here, this one. Because you have to take current of less than A. On the surface is same only.
Yes, sir.
Mu naught I R square by A square. How it has come? This is the one you have to do. This fraction. Fraction of current going is equal to area vectors. Area pi r square by pi a square. Pi r square is whole area of the conductor. Pi a square is, that is the where you are finding the magnetic field, that radius. You understood or not? Yes or no?
I understood, sir.
Say then it will go. So now in the first case, when R is less than A, this is B is proportional, so it will come straight line. When it is greater than A, it will be coming like this way. So this means here it will be. So from 0 to A, magnetic field is increasing. Once it is come out of the conductor, it will be decreasing. So here conductor is given two radius. One is outside, another one is inside. On the surface outside same. As it is most perpendicular distance, it will be decreasing. Okay, this I have taught you already. Magnetic
Yes, sir.
current is coming and you will get that uniform magnetic field. And this derivation you have to do now. Ampere circuit law B into L mu naught I. Okay.
Yes, sir.
L is equal to H. Length into number density will give you number of turns. So total number of turns will be N into H. That is how, because you know N by H is equal to small n. So N is equal to N into H. This N is called number of turns. N, small n is number density, linear number density. H is called length of the solenoid. What is the solenoid length is given here? See, H. This is the length, breadth. So actually magnetic field outside is 0, right? Perpendicular also it is 0. It will be only magnetic field exists A to B. So A to B means you are going to apply the Ampere circuital law for that magnetic field. So B into L. How many turns are there? You have to see. How many turns? N turns are there. N is equal to what is the formula? N into H. H is what? Length. So magnetic field outside is 0. On these lines are 0. Only it exists at the center. So this is the number of turns of the magnetic field in N into H. Number of turns threading the current on the magnetic field is, so H and L are same, so they will cut off. So you will get mu naught I N. Okay.
Yes, sir.
Next question.
Solenoid of length 0.5 meter and radius 1 centimeter and is made of 500 tons. It carries current of 5 ampere. What is the magnitude of magnetic field inside the solenoid?
Okay. Solenoid of length how much? 0.5 meters. L is given and radius is 1 meter and is made up of this much turns. So small n is equal to number of turns per length. This will be clear. Calculating what? B. B is mu naught, you know that is constant. N is number density, we get it 10 to the power of 3. And I is current. Just multiply, you will get answer.
Yes, sir.
Okay, this we have done already. And definition also you have done. Parallel current wire. Your definition is given. Definition of 1 ampere. If you want, you can read here. It is there. Oh, this is the definition of ampere. Just read here, you will understand.
Yes, so the ampere is the value of that steady current which maintained in each of the two very long straight parallel conductors of negligible cross section placed 1 meter apart in vacuum would produce on each of the conductors force of 2 into 10 power minus 7 Newton per meter of length.
This how it has come. I is equal to 1. IA, IB they have taken. We have taken I1, I2. D is 1 meter. So mu naught will be 4 pi into 10 to the power of. So 4 pi is divided by 2 pi. So you will get. You know how this answer has come? 2 into 10 to the power of minus 7, or I have to show?
Sir,
2 into 10 to the power of, this 2 into 10 to the power of minus 7, how this answer has come?
sir, here the distance between them is 1 and then 2 and then mu naught is equal to 4.10 power minus 7. So then 2.4 pi get cancelled, 2 is remaining.
Very
So
good,
you get
very
2
good,
into 10
very
power.
good. Enough. Go ahead. This one, you are doing well. Come on, 4.9 you do.
Horizontal component of the Earth's magnetic field at a certain place is 3 into 10 power minus 5 Tesla, and the direction of the field is form of the geographic south and geographic north. A very long straight conductor is carrying current of 1 ampere. What is the force per unit length and force per unit length on it? Um, from east to west and south to north.
Simple formula, force per unit length. You see first answer. If you don't understand, I will tell you on the board.
Yes, sir.
Formula is ILB sin theta. L and B are force per unit length is asking. A by L is equal to IB sin theta. Sin theta is how much? 90. How to realize it is 90? East to west. Current is flowing from east to west, and magnetic field is going from south to west. So the direction is south to north. So what is the angle? 90. Got it?
Yes, sir.
Sin 90 is 1. So this is your north. Okay, this is your east. This is your east, correct? This is west. So this is north. Always you remember. So current which direction it is given? East to west. So that is current is going like this. And magnetic field is south to north. So what is the angle between them is 90. So 90 degrees you have to take, then you just calculate. Then again, in the definition it is quoted how much? 2 into 10 to the power of minus 7. But we got is how much? Large force. It is a very large force will experience.
Yes, sir.
Then when the current is flowing from south to north, means in the same direction, theta will become 0. So force per unit length will become 0. Okay, na?
Yes, sir.
Say yes, then I will go quickly.
Yes, sir. Understood, sir.
Now this is the derivation. Torque. What is the heading? Torque on current
Torque
loop.
current loop.
Magnetic dipole. So here two strong magnets. One is north pole and south pole. And rectangular loop ABCD is connected to a strong magnet, strong cell. Yeah, and it is a cell is connected to slip rings, so that easily ABCD will rotate. Okay, there is a slip rings are given, so it will rotate. So when positive sign is at A, and what will be the sign here negative. So the current is flowing from A to B, B to C, C to D, and D to the slip ring. Again then it will be connected to this. So current is in this direction. Then now you apply the rule on this AB. What is the direction of the force? Because magnetic field is this one, north to south. What is the force on current direction is given, magnetic direction is given. Now you find out what is the force on AB.
Yes, sir. 1 second.
It is coming out of the plane of the screen or going in. You should understand that. Apply there, just magnetic field. You put your left hand rule, you take, put your magnetic forefinger in the direction of the B and current in this direction, and thumb indicates
Downwards.
downwards. Very
Four.
good, very good. It will be downwards. Very nice. And on this here, magnetic field is this direction. Again you apply same thing, current in this direction. What will be the C and D?
Sir.
on what is the direction of the force on C C and D current wire?
Yes, sir, 1 second. Sir, upwards.
Upward. So what is happening? It is rotating in clockwise or anti-clockwise?
Sir, upwards, clockwise, sir.
This arrow is showing now your angular velocity.
Sorry. Yes, sir.
Clockwise or anti?
Anti-clockwise.
So what is the formula? All 90 degrees, na? Force F1 equal IBB. I is what? Current. B is what? Breadth and magnetic field. And F2 again same here also, but it is in opposite direction. But torque is equal to what? F1 A by 2. Why? At the center, na? So it is rotating in the axis. This axis it is rotating. So A is divided into two parts. So BC will be divided into two parts, A by 2, A by 2. So that is shown here, A by 2, A by 2. So first force into perpendicular distance is this, that is torque on AB. And the second torque is F2 A by 2 in the CD. So when you add these two, you will get this. So I into A, what I told you, what is I into A?
I don't understand, sir.
Hmm?
Sir, what is?
No, you understood this derivation or not?
Yes, sir. Torque is equal to R cross F. R is equal to A by 2. F is F1 and F2, so.
Okay, two torques are there. First torque is A by 2 length, second torque is this. So A by 2 equal to A, and A into B is length and breadth, na? This is the length. Length and breadth will become area of the coil.
Yes, sir.
So I into A will become what? Force on BC and DA equal and opposite, and act along the axis of the coil. So they will not contribute any torque.
Yes.
This is another method. So I into A is what it is, I told you.
So force on.
No magnetic dipole moment, I told you na.
Yes.
Product
Yes.
of current and area is magnetic dipole moment. And if
Yes,
it is
sir.
B, A is vector, B is vector, then AB sin theta. If it is parallel, you will get a simple IAB. If it is with a certain angle, then you will get IAB sin theta.
Yes, sir.
This IAB sin theta will come with an angle. If there is no angle, 90 degrees, you will get IAB, IAB F, IBA, that is. When you go with an angle means A by 2 sin theta, A by 2 sin theta. That is explained here, this way. If it is not, B is not perpendicular to the current, at that time this one you have to use, this direction. So what is the direction of the M? It is normal to the plane of the coil.
Yes, sir.
So magnetic field and normal, if it is not parallel at that time, you have to take with an angle, then torque will come this. This is the torque. In the previous case, we simply taken A by 2 sin, A by 2. But in this case you can't take because sine function component function will come here.
Yes, sir.
To understand this, it is given very clear. You see, if it is in the this figure, see carefully this figure and other figure which I am showing here. Is there any difference or same? You can turn the pages in your notebook, textbook, and tell me.
Yes, sir. Uh,
Both the figures are same. Any difference you found?
Difference is there.
What is the difference?
So the coil is like it's spinning is this one, it's not spinning at all.
No, here current and magnetic field. Current and magnetic field is perpendicular to each other. But
Yes,
here,
sir.
here current and magnetic field are not perpendicular with an angle theta.
Okay, yes,
That
sir.
is why sin theta rule has come.
The big angle between them, sir.
Yes, correct. Here sine angle is vanished because you know that I B sine theta will come. Theta is 90 degrees, so it will become a 1 year. But here it is not one because it is with certain angle theta. That is what is mentioning here. So that is clearly explained. At that time, what will be the perpendicular distance? A by 2 sin theta will come. So that is why there we have taken simply a by 2, but here we have taken a by 2 sin theta come. Here also a by 2 sin theta will come. So a by 2 it will be a only and sin theta. So here in this equation, Ia is taken as constant. That constant is dipole moment, Ia, to make it meaningful. This is the one. Torque is M cross B. But what is the torque in electrical?
Sir, ILB, sir.
No. Electrical. Electrical means first chapter what you have studied. Torque in electrostatics is
One second, sir. I'll just.
P E sin theta. Torque in magnetism is
MB sin theta.
MB sin theta. Okay. Here this will become P cross E. Here it is given M cross B. Okay. M cross B. Cross product. So this is the way you have to compare magnetism and electricity,
Electrostatics.
electrostatics.
Sir.
It is written already. We see here electrostatic P is.
Oh, yes, sir. Yes.
It is also written. It is also. So book is explaining nicely. You don't read. That is the problem. And this is over. Then next. Yes. What do you want?
Sir, sorry to interrupt, sir. It's already 8:10, sir.
Okay. One more concept is there. Then after that, two more concepts will be. Tomorrow we'll do this or over. I think.
Sir, like tomorrow, can we finish off?
We'll finish
The
off this chapter, no doubt. I won't wait
yes,
because today I am taken all problems. Now it will take over 2-3 pages only there.
yes, sir.
Then again we will do. Okay, may I stop it?
Yes, sir. So sorry, sir, because I have a lot of school work to do.
Yeah, I understand because you note down what I am teaching because something is required proof that you are doing well. Okay?
Yes, sir.
So when I have not seen your written work at all, school work only there you are saying. But what way I have give confidence to your parents after spending lot of money?
Yes, alright, sir.
Already 1 week classes over. This is
I've been writing, sir. I've been writing the notes.
and then you take the photos and send to me. Na, I will be happy to see, and I'll give
Yes,
confidence
sir.
to
Yes, sir.
your parents. They are going on asking how, what way you are doing and all. What way I have to tell? Only I am explaining. Your work I
Yes, sir.
want to see
Yes, sir.
because I can't keep you online and do it work now. That is a great problem for me because I have to cover the syllabus which is coming. Your pre-board is going to start. That all pressure is on me. Okay, good night.
Sure. Thank you, sir.
I want you send photos whatever you have done. So many chapters are going on.
Yes, sir.
Okay, bye.
Thank you, sir.